Welcome everyone. My name is Tirnika from the Department of Artificial Intelligence and Data Science at Nada Saraswati College of Engineering and Technology. Today I will be presenting a seminar on fundamentals of time series in exploratory data analysis. In this presentation we will explore what a time series is, why it's important and how EDA techniques help us discover trends, seasonality and patterns hidden in the data. Let's get started. In this slide, we are going to see what does time series means. A time series is a sequence of data points recorded over time at regular intervals. Common examples include daily temperature, monthly sales, stock prices, and yearly rainfall. The main goal of time series analysis is to study how data changes over time and to identify patterns or trends that can help in forecasting the future. Components of time series. Time series data is made up of four main components. Trend. This shows the long-term increase or decrease in data, for example, the growth of companies' revenue over years. Seasonality. These are repeating patterns that occur at fixed intervals like festive season, sales every December. Cyclic variation. These are long-term up and downs over several years, such as economic cycles. Random or noise. These are unpredictable short-term fluctuation caused by irregular events. Importance of EDA in time series. Exploratory data analysis or EDA is the first and most important step in the time series project. It helps us to identify patterns, trends, and seasonality in the data. Detect missing values or outliers. Test stationarity, that means checking whether the average and variance remain constant over time. And finally, select the right model of forecasting like ARIMA or Profit. Key EDA techniques for time series. Some of the most useful techniques used during EDA are line plots to show the overall trend and direction of data, box plots and heat maps to visualize how data changes across months or years, autocorrelation and partial autocorrelation to find relationship between current and past data points, rolling mean and standard deviation to check data stability and smooth out fluctuation, decomposition to split data into trend, seasonality and residual components. Here we can see an example Python program that performs time series in EDA. It uses libraries like pandas, matplotlib, seaborn and etc. The code first creates sample monthly sales data, converts dates into proper format and sets them as the index. Then it visualizes the data, calculates rolling averages to show trends and decomposes the series to identify trend, seasonality and noise. Finally, it plots the box plot to display how sales vary each month. The output includes several plots, a line graph showing sales growth over time, a rolling mean plot highlighting the upward trend, a seasonal decomposition chart separating trend, seasonality and the residuals, and a box plot that clearly shows monthly sales patterns. From these results, we can observe that sales show a steady upward trend and slight seasonal variation. Time series analysis is widely used in many fields such as finance for stock market forecasting, weather prediction using historical temperature data, business and sales to forecast demand and manage inventory, healthcare to track patient statistics or disease spread. In short, time series analysis helps convert historical data into meaningful insights and future predictions. To conclude, time series in EDA allows us to understand patterns over time, identify trends, and prepare data for the accurate forecasting. It forms the foundation for advanced predictive models in AI and data science. Thank you all for listening.